In this lecture, we're going to learn about range algorithms. And this is another set of algorithms that are part of the C++ standard library that allow us to do all kinds of crazy things. But they are different from the algorithms we saw in the last chapter in that they don't work on iterator pairs, they work directly on the containers. I think this is best explained with an example, so let's look at one. Here is an example of what we did from the last lecture for the std_al_of algorithm. And to use it, you remember that we had to specify the beginning iterator and the end iterator. Doing this all the time for the sake of calling the algorithm that is going to work on the entire container was annoying enough for the C++ designers to come up with a way to eliminate these iterator pairs and let us directly pass the container that we want the algorithm to work on. And they set up something like this in C++20 now, so we can call our algorithms without specifying the iterator pair. We just specify the container we want the algorithm to work on, and this is going to work really well. The compiler is still going to be using these iterators under the hood, but they are not going to be exposed in your code. And this is a simplification we have in C++20. The rest is really what we saw in the last lecture. This algorithm is going to tell you if all the elements in the collection satisfy this predicate. In this case, we're going to know if they are odd or not, and we're going to say that in our output statements here. If we come back to the documentation at CPP reference here, we're going to actually see that each algorithm is going to come in two versions. We're going to have an iterator pair version for the algorithm as we see here, and we're going to have a ranges version of the algorithm, which is going to be living in the std ranges namespace. For example, we can open up the ranges_al_of version for ranges, and we're going to see the documentation here. You can read all you can about this. We're going to have information about the parameters, the return value, and if we go down, we're going to find a bunch of examples we can use to really play with this algorithm here. And if you go down here, for example, you're going to see that we are passing the container as a whole instead of passing in an iterator pair. Okay, this is the basic idea behind range algorithms. Let's look at a few other examples. Here we have the std ranges for each algorithm, and we call it like this. This is going to loop through the collection, passing this predicate and using it to do modifications on each element in the collection. And we're going to look at an example in a minute when we hit Visual Studio Code. We can use the sorting algorithm, and this is going to sort numbers in our collection. And again, we are passing our container as a whole, and this algorithm is going to live in the std ranges namespace. This is important to notice here. We can try and find things using std ranges find. It is going to be living in std ranges, the namespace, and we're going to call the algorithm without specifying an iterator pair as we see right here. And this is going to find a given element in our collection. If the element is found, we're going to know that and check against the end iterator. And we're going to know that with this output statement here. If we don't find it, we're going to say that right here. One other important thing I want you to notice is that it is also possible to use the copy algorithm and put data directly in an output stream, and this is really cool. The syntax to do that is by using the copy algorithm. This is also going to work for the iterator pair algorithms, but I thought it was a good idea to show that to you here because it's going to simplify your code a lot. And if you see something like this in code out there, I want you to understand this. So this is going to say std ranges copy. This is going to be copying stuff from a collection that we pass here, which is going to be our numbers. It is going to be writing these elements to the output stream, which is std_cout, and we will have an iterator, which is going to be looping on integer elements. And this iterator is going to be iterating, copying numbers from the container and putting this in our std_cout stream, and it is going to separate data using this empty string here. This is what we mean with this syntax. This may be clunky and weird to look at the first time, but if you use this a couple of times, you're going to understand how this works. One important thing to remember is to specify the type that this iterator is going to be iterating over, because if you don't pass it, the compiler won't know the size of the things that you are iterating on to be able to separate them properly and put them in stdc out. So if, for example, you have int data in your collection and you pass std string here, this is going to confuse your compiler and you are going to get a compiler error. If you want more examples on this algorithm, you can go to CPP reference and learn all you can about them. You're going to find a bunch of these algorithms, but I am just going to show you a few examples to get you started on this, because you already know most of these algorithms from the last chapter. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is range algorithms. We're going to grab our template files and put them in place. Let's do this. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can close the left sidebar here. We don't need it. And we're going to remove what we don't need. And because we're going to be using algorithms, we are going to include the algorithm header, just like in the last chapter. So let's do include algorithm. I believe we will also need the vector header. So let's put this in. And then we're going to put in our trusty print collection function we used all the way in the last chapter. We are going to hop over in the main function and put in our algorithm. We're going to start by setting up a container, which is going to be an std vector of integers. As you see here, it is going to contain data, and then we're going to print the data. And after that, we're going to try and test and see if all the elements in our collection satisfy a given predicate. Our predicate is going to test and see if the numbers are odd, and we will use this lambda function here. And the mate of this example is going to be the call we have on line 30, which is going to use the std ranges all of algorithm to test and see if all the elements in our numbers collection satisfy the odd predicate. In other words, we are testing to see if all the elements in our collection are odd. If they are odd, the result here is going to be true, and we're going to print that out here. If all the elements are not odd, we're going to print that and say that on the terminal here. This is something we can do, but notice that this algorithm is going to be living in std ranges all of, and it is different from what we did in the last chapter, where all our algorithms were living in the std namespace. This is really critical to understand. With this in place, we can try and run this through our compiler. We're going to use GCC, our favorite. The build is good, so we can bring up a terminal window. Let's clear and run Rooster, and we're going to see that all elements are not odd in our collection here. This is the output we have right here. We can also try the for each algorithm, and this algorithm is going to loop through the collection, doing something on each element in the collection. You already know this from the last chapter, but now we're going to see a ranges version of this algorithm in which we won't pass an iterator pair, we will pass the container directly, and we can do something like this. This is going to apply this transformation to each element in the collection. So it will basically take each element by reference, and then we're going to multiply the element by 2 using a compound multiplication operator, and then we're going to assign back the result in this n variable. The result is going to be that each number is going to be multiplied by 2, and we're going to see that if we print our collection again. Let's pass this through the compiler to really see this with our own eyes. The build is good, so we can clear and run Rooster, and we're going to see our collection printed out for the first time here. And the second time we print it out, we're going to see that each element was multiplied by 2, and this is what we expect. We had an 11, now we have 22. We had a 2, now we have a 4. And everything is really following the predicate that we passed in here, which is going to multiply everything in the collection by 2 because it is taking each thing by reference. This is something you can do with the for each algorithm if it makes sense for whatever problem you are trying to solve with C++. We can also use the sorting algorithm, and let's put in an example, which is going to be very simple now. We're going to have our collection printed out. We're going to sort it out. Notice that we are passing the container as a whole, and our algorithm is going to live in the std ranges namespace. So this is a range version of our sorting algorithm here. And after we print again, we're going to see that our elements are going to be sorted from smallest to largest, because this is the default in our sorting algorithm here. We can pass this through our compiler. Let's do this. The build is good, so let's clear and run Rooster, and we will see that our data is going to be sorted. We had then the data which wasn't sorted, but now it's going to be sorted from 4 all the way to 34. And this is something you can do in your C++ programs if it makes sense for whatever you are after. I am also going to show you another example, and this one is going to be about std ranges find. We're going to use the find algorithm, and this is going to be a ranges version, as you see right here. And we're going to find if we have at least one element that satisfies this condition here, and that's going to be odd. If at least one element is odd, this is going to return the position where that element is, and we're going to know that we have that element. We're going to print that out here. If we don't find it, we're going to fall right here, and the check we are doing against the end iterator here is going to fail. This is a good testimony that with range algorithms, iterators don't completely disappear. Sometimes you need them, and you see here that we need to check against the end iterator. So iterators are going to show up sometimes, even if you are using range algorithms. That's why I put in this example here to really drive this point home. We can pass this through the compiler, and we're going to use GCC. The build is going to be good, as you see right here. We can clear and run Rooster. And we're going to see that now our container doesn't contain any odd number, because all we have in our collection is really 4, 6, 8, 12, and all these lines you see here. So we don't have any odd number. This is the result. The last thing I am going to show you is a really cool syntax you can use to print collection data into stdcout with a single line without really doing in loop like we have been doing all along. And this is going to simplify your code, but the downside is that this is not very readable. If somebody looks at line 71, it's really hard to come up with an idea that you are trying to print on stdcout. But what this algorithm is going to do is to copy. You see, it is the ranges version of our copy algorithm. It is going to be copying each element in our numbers collection, and each element is going to be passed to stdcout. The algorithm will use an iterator it gets from stdoutstream iterator. It is going to be an iterator that iterates over integer data. This is what we say here. And the iterator will keep iterating through the numbers collection, grabbing each element and passing that to stdcout. And the elements are going to be separated using a simple empty string. And if we pass this through the compiler, we're going to see that this is going to build, and we will print each element in the collection on the terminal. And this is really cool. Let's pass this through the compiler. We're going to use GCC. The build is going to be good, so we can clear and run Rooster, and we will see that our data is going to be printed out just like we see here. And we are able to do this with a single liner we have on line 71, and this is really cool. One thing you need to keep in mind is that this is even going to work if we use iterator pairs. So if we pass numbers begin here and numbers end, let's do that. This is also going to work. You see that the squiggly lines are going to go away. And if we pass this through the compiler, the build is going to be good, hopefully. So the build is good. Let's clear and run Rooster, and we will see our data printed out here, even if we are using iterator pairs. I think this is really not iterator pairs, so let's do std here and take the ranges out. This is going to be true iterator pairs. We can pass this through the compiler again. And the build is good, so let's clear and run Rooster, and our data is going to be printed out. Let's pass this back to be using ranges algorithms, because this is really cool. This is going to simplify code if you have C++20 available for your project. And we're going to end up with something like this again. Let's pass this through the compiler again and make sure this is working. The boot is good. Let's clear and run Rooster, and we will see our data printed out right here. This is really all I had to share in this lecture, giving you a simple overview of Range's algorithm. If you want the whole thing, you can come back to the documentation. You're going to see all kinds of crazy algorithms you can use. The main idea is that with Range's algorithms, you won't have to use iterator pairs. You can pass the container directly, and the algorithm is going to work on it. Another thing is that these algorithms are going to be living in the std ranges namespace. This is not obvious here because they are bringing in the ranges namespace somewhere in the program here. But what I prefer to use is say explicitly std ranges and specify the algorithm that I want to use with a syntax like this. This is going to be much more explicit and easy to understand. We are going to stop here in this lecture. In the next one, we're going to learn about projections, a really big and important feature in C++20 ranges, and this is going to be really cool. So go ahead and finish up here and meet me there.